In question 11, we have been provided with the equation for this quadratic in intercept form. We've got the two intercepts at -2, 0 and 4, 0. And we're asked in part 1 to write down the value of P and Q. Now, write down means you should be able to establish it fairly simply without having to do any real calculations. And we should recognise from intercept form that this is going to be y equals a brackets x plus 2 x minus 4. So that's just taking the solutions here. X equals -2 and incorporating them into the bracket. Same thing here. X equals 4. If we incorporate that, we can rewrite that as x minus 4. So there's 1 point each for the P and Q. But we don't know what A is. In order to figure out this value of A, we must have at least one other one point on the curve and have the corresponding x and y values. So we're given that information in part 2 because it tells us the point 6,8 is on the curve. So what that enables us to do then is to substitute in the values. So we can substitute in 8 for y. A is an unknown, we don't know. So we can say that x is 6, so 6 plus 2 is going to give us 8, multiplied by x minus 4, so 6 minus 4 is 2. We can establish then that 8 is going to be equal to 16a, so therefore a is going to be equal to a half. In order to write the equation of the curve in the form y equals ax squared plus bx plus c, which is required in part 3, we can then substitute this value back into our original equation up here, and we end up with y equals half x plus 2 x minus 4. So all we have to do then here is just to expand and simplify. So we can say that y is going to equal a half multiplied by what we get when we expand this, which is going to be x squared minus 2x minus 8. And we can simplify that to give us x squared over 2 minus x minus 4. The first part of B is fairly straightforward. We're just asked to differentiate the equation that we found previously. So all we need to do there is just straightforward differentiation. So this is going to give us x minus 1. That's all you need to do, just differentiate each of these terms individually, and obviously the constant term will just disappear. In part 2 then, we're told that a tangent is drawn to the curve at a point P. We're told that the gradient of the tangent is 7, and we're asked to find the coordinates of P. So in order to do this, we know we've just found an equation for the gradient function. So the tangent to a point, the gradient that we found using differential calculus will be equal to this value here of 7. So 7 will be equal to x minus 1. So we can establish that the tangent will be 7 when the value of x is equal to 8. And then we can use that to establish y by just taking this value of 8 and substituting it into this equation here. So we can say that y is going to be 64 over 2 minus 8 minus 4. And if we do that, we're going to end up with a value of 20. So the coordinates of the point P are going to be 8, 20. In order to get to grips with the final part of question 11, you need to make connections with perpendicular lines. So the key concept here is that if you have two lines which intersect at right angles, so if we call this one the first line and the gradient denoted m1, and this second one here will denote the gradient by m2, if they are perpendicular, the product of these two gradients will give us an answer of -1. The other way you can think about this is by saying that, well, for instance, if we rearrange it, m1 is equal to -1 over m2, or the negative reciprocal. So this is a key principle that we've seen in GCSE, but we need to draw on this here. We're told that we've got a line L which passes through the point B with coordinates 4, 0, and it's perpendicular, so this is the giveaway sign here, to the tangent to the curve at point B. So the first thing we're going to have to do is find the tangent to the curve at point B. How are we going to do that? Well, we've already worked out previously, this is our gradient function here. So we want to find the gradient at point B, which has an x-coordinate of 4. So all we're going to do then is substitute in 4 into here. So at B, let's call that the gradient m1 is going to be equal to 4 minus 1, which is going to equal to 3. If the gradient of m1 is 3, then we can rearrange this here and say the gradient of m2 is going to be equal to negative 1 over 3. Now that we've got the gradient, we can then substitute that into the y equals mx plus c equation. So if we've got y equals mx plus c, we've got the gradient negative 1 over 3, and we've got a point on the line here. So the y coordinate is 0, which is going to be equal to negative 1/3 x, which is 4 plus c. So we can rearrange that in order to say that c is going to be 4/3, and then our equation is going to be y equals negative 1/3 x plus 4/3. In part 2, we're asked to find the x-coordinate of the point where line L intersects the curve again. So essentially, you've got just something kind of crudely where you've got a quadratic and you've got a line linear function. Now we can see that, for instance, here there's going to be 2 points where the straight line intersects the function. We found one of them. We were essentially asked to find the other. So in order to do this, again, the most straightforward way of doing this is just to set the two functions equal to each other. You could do it graphically, but to work it out, we're just going to set them equal to each other. So we had to show earlier on that the equation of the quadratic is half x squared minus x minus 4. And we're going to set that equal to the linear function which we have just found. And we can rearrange that, so we will get half x squared minus 2/3 x minus 16 over 3 is going to be equal to 0. And we can either solve that on our calculators, or we could multiply 3 by 6, which would give us 3x squared minus 4x minus 32 equals 0, and try and solve that. So we would get 3x plus 8x minus 4. However you solve it, you should end up with a value of x as equal to negative 8 over 3, or the other solution which we have already looked at previously, because we were given point B, is 4. So the only solution that we need to get for the mark here is negative 8 over 3.